Hi, this is Mark. We're going to here have Tom Newton, who's going to do some demonstrations for us. So currently, almost most of the reactors that operate in the world are light water reactors. There's like not a whole lot of diversity in terms of nuclear reactors that operate across the world, but there's a lot of ideas for new types of reactors to be built in the future. And in order to know whether certain ideas are going to work or not going to work, we have to do materials testing. So we have to test out new kinds of materials, see what happens to them in a neutron flux in a reactor. So this is a research reactor we have here at MIT. And one of the main things we use this for is to test out new kinds of exotic materials that have not been used in reactors previously to see how they behave in a reactor, see how they would behave in like a large-scale commercial reactor before we actually go and build the thing. And so we put these materials in the reactor to irradiate them with the neutrons, and then once we take them out, they are radioactive, so we can't touch them. So we put them in what's called a hot box. And we handle them remotely with these mechanical tools that Tom's going to demonstrate for us. So these are materials, right? Those are materials that were in the reactor and that were irradiated by neutrons. And so now they've been taken out and they're kind of sitting in here protective. And so we can handle them with these mechanical arms and like do analysis on them and do testing of them, because we can't actually touch them because they're radioactive. So one of the main things we test for in these materials after they've been in the reactor is like, for example, how much they swell. A lot of materials, once they absorb neutrons in a reactor, they tend to expand because of the different reactions that are happening in the material, and we need to know how much they're going to expand by before we put them in a new type of reactor design. And so once they come out of the reactor, we put them here and test and measure things and see how much they've expanded and what kind of things the neutron flux has done to them.